In section 5.4, we're going to continue our discussion on different relationships that occur within triangles. And so today, in this video, we're going to be looking at medians and altitudes of triangles. So first of all, we need to know what that means, okay? The altitude is a fancy name for the height, okay? And it is the perpendicular segment from a vertex to the opposite side, or it's the line that contains the opposite side. Do note here it can be inside or outside of the triangle. Namely, in an obtuse triangle, it can be outside. And so if you look at the triangle here on the left, if I want to look at the altitude with respect to vertex A, then what you have to do, if this is triangle ABC, let's call it, then what you'd have to do is you'd have to actually carry out side BC a little bit further. And then your altitude is that guy right there, okay, whatever that height is, whatever that distance is. Okay, and so in the other triangle, obviously it's a little bit more clear because all you do is go from this vertex straight down. That would be your height, or again, mathematically speaking, we'll use the term altitude interchangeably with height. The median of a triangle is a segment that goes from a vertex to the midpoint of the opposite side. So again, there's three of them in a triangle. So in this particular diagram, if I do this, okay, and I can show you that that's a median by just simply marking this. So that shows you that this point here is the midpoint. Therefore, it must be the median. Now, as I said, every triangle has three of these, okay? And that those medians will always intersect at one point, okay? And that point is called the centroid. We can also call it the center of gravity. Means the same thing, okay? And the unique thing here is that we can actually find the coordinate of the centroid if we put the triangle on a coordinate plane. All you do is average your x values and average your y's values. That's it. You're going to have three of them, obviously, because you have three vertices of the triangle. Do note, though, that the centroid will always be inside of the triangle. So if you go through and you find the centroid or the center of gravity to be a point, and when you plot that point it lies outside of the triangle, clearly that is going to be incorrect. Okay, example 1, we're just kind of reviewing here. It says name each special segment. So in part A, AC goes from one vertex to the midpoint of the opposite side. Therefore, that thing is a median. In part B, HE goes through the midpoint and is perpendicular. Therefore, this thing is a perpendicular bisector. That was section 2. Example 3, JL cuts this angle in half. Therefore, it's an angle bisector. And lastly here, NP, since all we know is that it's perpendicular, is obviously just going to be an altitude. So those are the four primary things that we've discussed thus far in Chapter 5. Okay, so RS is an altitude of RTE. As soon as you know that, what you do know is this. It's got to be a right angle. The measure of SRT, so SRT is this angle here, is 4x minus 8, and STR, this angle, is 6x plus 13. A couple different ways you can do it. You know the angles inside of a triangle add up to 180, or you could say, hey, if this one's 90, that means that these two have to add up to 90. So in other words, we know that 4x minus 8 plus 6x plus 13 has to equal 90. So when I combine like terms here, I get 10x plus 5 equals 90. Subtract your 5 from both sides. So 10x equals 85. And then we finally divide by 10, which says that x equals 8.5. Okay, and that's all it says. It doesn't say find the measure of the angle. So once I know x is 8.5, I'm done with the problem. Okay, in example 3, we're given the three vertices of triangle JKL, so I'm going to go ahead and plot those right away. So let's see here, J is the point 1, 2. K is the point, so let's label that J. K is 3, 8. 1, 2, 3, 1, 2, 3, 4. So there's K. And then L is the point 8, 4. Okay, so here's our original triangle here that we're talking about. And the second part of it says we want to use the midpoint formula to find the midpoint of each side. Okay, so that's not very difficult. So I'm going to do the midpoint of, I got to do the midpoint of JK first. And then I'm going to do the midpoint of KL. and then I'm going to do the midpoint of JL. And again, all you do is add up your x's, divide by 2. So JK would be 1 plus 3 over 2, comma, 2 plus 8 over 2, which is 4 over 2. That's 2 comma 5. So 1, 2, 1, 2, 3, 4, 5. And then for the second one, add up your x's. So I'm looking at KL. So 8 plus 3 over 2, comma, 8 plus 4 over 2. That's 11 over 2, comma, 6. So 5.5, comma, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So clearly my picture's not drawn to scale here. And we kind of assume that based on the fact that I don't have an exact utensil. I'm just kind of sketching. So, and then for the midpoint of JL, again, same idea. So 1 plus 8 over 2, comma, 2 plus 4 over 2. So that's 9 over 2, comma, 3. So 4.5, comma, 3. 1, 2, 3, 4.5. 1, 2, 3. That one's pretty accurate, so that's good. That worked out. Let me mark that with a different color. There we go. Okay, and so your three medians are 1, 2, 3. There's your centroid. Okay. The last part here, part C, says find the coordinates of the centroid. So again, all we have to do here is average the coordinates of the vertices. So when I look here, let me scroll down a little bit. There we go. Okay, so the centroid has the coordinate, and again, it's just add up all your x's and divide by 3 now. So I do 1 plus 3 plus 8 divided by 3. Most common mistake here is people divide by 2. And then I have 2 plus 8 plus 4 divided by 3. So I get, let's see here, as I simplify, 3 and 1 is 4. That's 12 over 3, comma, 14 over 3. The 12 over 3 clearly simplifies to 4. The 14 over 3 we'll just leave as 14 over 3. And so there's the coordinate of the centroid, 4, comma, 14 over 3. Okay, example 4 says find the coordinates of the center of gravity. So again, all you're doing is exactly what we just did in the last part of the previous example. Average your x's, average your y's. So center of gravity, just another name for centroid, -3 plus -5 plus 2 over 3, and then 5 plus 8 plus 2 over 3. And so now when I simplify this, I get, let's see here, that's -6 over 3, comma, 15 over 3. And lastly, that's -2, comma, 5. All right. In example 5, I'm going to go ahead and let you guys go to work on those. It's the same idea. Find the coordinates of the centroid first, and then just simply plot the point. Okay. So in that example, all I'm doing is I'm giving you the graph instead of just telling you what the coordinates are. So again, hopefully this section is pretty straightforward, just looking at medians and altitudes. We'll look at some more applications in class as well, but if there are any issues with these notes, please bring them to my attention and we'll get them answered.